Hello, everyone. Welcome to Microsoft Reactor's Our Build Skills series. This workshop is going to focus on get started with Jupyter Notebooks for Python. What a great topic. Jupyter Notebooks was one of the most amazing things that I discovered a few years ago. I'm Justin, and I'm joined today by Ricardo as well. Welcome, Ricardo.
Hi, thank you, Justin. I'm Ricardo. I will be presenting this with Justin here. I'm a Gold Microsoft Learn Student Ambassador. Very excited to be sharing this content with you today.
Yeah, it was good getting to know you a little bit before this, Ricardo. So thanks for joining us today. And part of this series for all of you out there listening or will watch this on demand is that we really want to focus on beginner skills and to not assume prior knowledge of some of the most kind of amazing technologies and things that are really driving innovation in the data sciences and in other things like that. So we're going to begin with Jupyter Notebooks, how to use them, how to use Visual Studio Code and things like that. And contrary to what the slide says, my name is not speaker name. I'm Justin. I'm a principal program manager, cloud advocate here at Microsoft. And this is our series to kick off. So I also just wanted to extend a welcome to the Reactor community, but also students and Microsoft Learn student ambassadors. We're trying something a little bit new here where our Reactor community is traditionally a place where professionals gather in locations all around the world, digitally online, on Twitch, on YouTube. And we have programs for students that are enrolled in universities, technical schools, 2 years, 4-year college. It doesn't really matter so long as that you identify as a student and as a learner. And so we're trying to kind of bring these communities together. And so if you're a student out there, we invite you to learn here and really get involved potentially in the Learn Student Ambassador program like Ricardo is here as well. And at the end of this stream, we are going to do what we call a train the trainer or just kind of a Q&A. And we're going to give you all the materials that you learn in this workshop on a GitHub repo. And you can go and deliver this yourself to your communities. Maybe you're a teacher, maybe you're a STEM volunteer. All of the content that we'll share today is generally appropriate for people who just want to get started with Python and Jupyter Notebooks. Last quick thing, this is part of our Microsoft Reactor Code of Conduct. Of course, read our slide here, but be respectful, be aware of others, and share your perspective. We really want to hear what you have to say. We want to hear some questions. Hello, those out in San Diego. Hi there, we're from Seattle. Ricardo, where are you based today here as well?
I'm in Utah.
Very good. So we got good representation in the Western United States. Yeah, holler out to us. Ask us questions today. We really do enjoy this. And then finally, just a quick announcement. This is part 1 of 2. If you really like what you see today and are learning, next week we'll be covering a little bit more of an advanced topic on the spectrum, which is starting to clean and prepare data using Python. So that you can build up to that as well. The URL for that meetup event is available there. We're going to try to paste it in the chat window so that you don't have to copy that from memory as well. All right, finally, all of this that you can learn today is on Microsoft Learn. In fact, I'd encourage you to pop open a web browser and type in aka.ms/Jupyter Notebooks for Python. We're going to cover this in a live demo today, but you can follow along directly in Microsoft Learn. In fact, I actively encourage that. You also get points for that, and you get a profile, and you can build your skills that way. As well. But if you also want to just pop open VS Code, which we're going to share in a minute, and follow along, you can do that as well. All right. So as I mentioned, this is a workshop primarily for beginners. We do think that you should have basic programming concepts. I'm not going to be writing any original code today. We are going to share some code blocks, and we're going to explain those a little bit. But you don't have to write code originally either. So this is a really good approachable way to kind of learn. And we do want you to have Python 3 installed locally. If you haven't, we're going to set that up here in just a minute. By the end of this, you should be able to create a Jupyter Notebook, let alone know what a Jupyter Notebook is. Run one using Python and Visual Studio Code. What's really cool about that is that you're not costing compute cycles in cloud. And so all of this is free. It's a free download, and you're running your code ultimately on your local device. And we're going to talk a little bit some of the ways to build a notebook and explore and learn on your own as well. All right. Yes, we are going to do a knowledge check at the end here, just to test you. So there will be a quiz, but we won't be scoring it at the end. It is on Microsoft Learn though, if you want to check that out. All right. So let's just kind of put Jupyter and this programming in context. So first of all, there are many different tools to build websites, to build applications, to experiment with data science and things like that. And most web applications, most native applications, the kind of things that you might see on your phone, your Android or iOS or your Windows device or things like that, will be written in languages and compiled ultimately into an application experience. That is the game that you run or the mobile app to read your news or things like that. And so we have great technologies for that. Node.js for web development, as well as ASP.NET. Java is a programming language that's commonly used in Android, amongst many things and such. But what makes our discussion today very unique is we're using a very general purpose programming language that is Python. Python has become pretty popular in the last few years. And a lot of the reasons for that, amongst many, are that it's been adopted very widely by the academic, research, and data science communities. And so it is often the programming language that many people choose when trying to learn machine learning, statistical analysis. It's a great language to learn how to code. I certainly have found a lot of value in myself in comparing it to other languages I've learned in the past as well. And so that's Python. And so we're going to add a layer of abstraction to that. We're going to call those Jupyter Notebooks. And so Jupyter Notebook is specifically a Python environment that facilitates interactive programming. In other words, it feels kind of like a real tangible notebook, the sort of thing where you'd write some notes in the margin, and then you'd write your code or your math here or things like that. And so it's one of the things that I really personally believe it's one of the most approachable ways to learn how to program. And especially if you're an aspiring data scientist or you're involved in a profession where you're working with data analysts or data scientists, just having some knowledge of this, even if you don't end up coding on a day-to-day basis in your job role, is particularly useful. Jupyter is an open source. It was adopted and made by the community a few years ago. It has grown. It does support more than just the Python programming language. So you can use the notebook-like environment on other languages. But for our purposes, we're going to be writing some Python in a Jupyter notebook that ultimately runs in VS Code, Visual Studio Code, which is a code editor that we'll be using as well. So our scenario today is a little bit space themed here. And this is just to kind of put, I think, this stuff in context. But so suppose you were a crew member on a spaceship. A lot of science, especially the natural sciences, uses data science techniques to collect data, to visualize data, to observe that as well. And so our scenario is you are a member of a person on the International Space Station, and you're supporting a crew of people. And you've got to produce some documentation, some interactive things that help fellow scientists, astronauts, or other people that may not be fluent in programming or may not be their primary job role. You've got to give them something simple and easy to be able to calculate, to understand, and things like that. And so we're going to build a couple notebooks real quickly with a little bit of a space-focused theme here. These are very, very simple examples. There's so much more you can do with Jupyter. We're just going to scratch the surface here. But the purpose is just to write a few lines of code and get to know our environment as well. By the end of it, you're going to create a Jupyter notebook locally. We're going to run that notebook using Python and VS Code, and we're going to describe some ways to build that. So with that, let's go ahead. I want to switch over to you, Ricardo, and would you start to help our learners here set up our environment?
All right. So let me share my screen real quick, just to show a couple of the websites. I'm assuming you do not have anything installed. And
Yeah, I think we should assume that. Let's give
Yeah.
people a chance to install. We can take some questions in the chat window while we're doing that. And Ricardo, yes, if you could share your screen, I'll add you to the stream here.
All right. So
there we go.
The first thing that you need to install, and this is for Windows or Mac users. If you're using Linux, you probably have most of these tools installed already. But so just go to python.org, and then you just mouse over downloads, and you should see a button here. And once you click at it, and it's going to download here for you. I'm not going to install that because I have this installed already. But it's a pretty much straightforward installation. It's going to show several options. You can just pretty much click, and you shouldn't have any problems doing that. Once you're done with it, just go to code.visualstudio.com, and then again, just hit download, and it's going to automatically download that for you. And if it doesn't, just click the blue button up here, and same thing, just go through it, install everything. And the order in here is kind of important. So probably if you've never installed Python before, you might have to reinstall to restart your computer so that it gets added to the environment variables on Windows if you're using Windows. Mac, I don't think that's an issue. But then if you do that, once you open this, it's going to take you to the Visual Studio Code. So this is how it looks like. Basically, you're going to see a little less buttons down here because I have other extensions. But you can open folders, you can open files, and pretty much this allows you to run code in virtually any language there. So we're focusing on Python now. So the next step would be installing the Jupyter extension. So there's this button here, extensions. You can hit Ctrl-Shift-X as well if you're on Windows. So this is 4 squares. One of the squares is flying a little bit. Just type in Jupyter on the search box. And the extension you want is this one by Microsoft. So Jupyter. And it's going to install a few other things. And once you do that, you're almost ready to start developing and working with the extensions. If you want to make sure that everything is installed, and I think that is a good idea, if you run into any problems, just open your console or terminal, or depending on the system you have, and just type in a Python version, and it's going to show if you have the version installed. It's going to show. If it doesn't show anything, then probably something wrong with your installation. I have ran into a problem once in which I had to install through the Windows store to make it work in the Windows machine. So if that's your case, try that and see if that works for you. And once you're done with all these things, installing Python, Visual Studio Code, and the Python extension, again, it's the extensions tab, type in Jupyter, install up here. There's going to be a button here to install. And then you should be fine and good to go and ready.
Awesome.
Yeah, I'll pass the time to Justin so that we get started with our first notebook.
Yeah, thanks, Ricardo. And a couple things to add for those of you that are pretty new to VS Code or to extensions or things like that is what we're doing here ultimately is we're installing 3 key things that you need in order to be able to write Python code in VS Code in a Jupyter Notebook. And those 3 things is, first of all, you need a runtime, a language, in this case, Python. VS Code is the editing environment that you use. And what's really cool about VS Code as a code editor is that it offers extensions. And that's what Ricardo is saying is it's not it's not just something for Jupyter. It's something that, in fact, let's say you want to build with containers, or you want to build AI services that hook up to the cloud, whether it be the Microsoft Azure cloud or other clouds out there. And so VS Code is extensible, and that's what makes it, amongst many things, very, very useful as a programmer and as a person who's learning, because really you can pull anything you want and you can experiment with it very easily. So why don't I go ahead and share my screen here as well. And you'll notice my Visual Studio Code is a light theme. So Ricardo has a dark theme. That's up to you. That's part of the fun. It's your own code editor. So I thought I would just offer a little color contrast here as well. And what you see here is basically the landing of Visual Studio Code when you first install it as well. So I'm going to go ahead and create my very first Jupyter notebook with this as well. But just to draw your attention to, your extensions are right here, as Ricardo mentioned. You can debug. You can see. You can add your programming and adjust your light and dark colors here. You can add your own identity. Lots of cool things you can do in VS Code. But what I'm going to do here is I'm going to open a command palette. I did that pretty fast, so it's on the View menu here. And it pops open this little search box here with things that I have recently done. And at the top, because I was prepping for this workshop prior, is Create New Jupyter Notebook. So if you're with us there, and it's okay, again, if you have not got done installing some of the things that we mentioned earlier, you can catch up pretty quickly. This will be available on demand, but you can also follow along on Microsoft Learn as well. So what I'm going to do is I'm going to create a new Jupyter notebook here. And you can see here, it just looks like, untitled document here. The extension for a Python notebook is IPython B, IPYNB. There might be a knowledge check question of that at the end of the workshop, so worth knowing as well. And so what we've done here in Visual Studio Code is we're actually running the Jupyter kernel inside VS Code. And that allows us to do some really cool things, like we can add a markdown box like this. And it can say something like, let's see, let's go, welcome to Jupyter Notebooks. And because I'm a perfectionist there, I add my space. And I can basically add a text block alongside a code block. And what makes this so unique is that I can actually make this feel, again, like a notebook, where I'm explaining what I'm about to write, kind of like commented code, but then I'm actually going to execute code in individual blocks. And so what I did there is I clicked on the plus markdown, and I created a markdown box. And now I'm going to create a code block there. And so let's say this is where I'm going to run a little bit of Python code. Let's just say, let's start with something simple here, like print hello world. Streaming product is delaying my keyboard a little bit there. And so print hello world. So I do that. And then you see this little triangle for play here as well. And I can click that. And it asks me to select kernel. If you have multiple versions of Python installed, you can pick any of these for the level of code that we're writing today. And you see there now VS Code has now entered IntelliSense and has color-coded my code block there. And of course, I'm just going to hit run. Gives me a little time. In 1.2 seconds of runtime, a little fast. There we print hello world. Very cool. Very simple, but what's really profound about this is that unlike you might be writing a bunch of code and then compiling it at the end, what makes Jupyter Notebooks so unique is that you can actually write code in sequential blocks, which makes it really ideal for experimentation, for learning, for data science and machine learning, because let's say you might be manipulating data and you're trying to find patterns about that data, or you're trying to clean up that data, or you're trying to spot anomalies or things like that. Well, you can do so iteratively by being able to run these individual blocks of code as well. I see that someone on the chat here says I'm not able to see the run button. It's a little bit tricky in VS Code here, but the run button is actually this little triangle. Maybe I hit that pretty quickly. But you can also do Control-Alt-Enter to run it, similar to a Jupyter Notebook and other implementations. Or you can, at the top here, you can run all. And of course, clearing your output, restarting are going to be important a little bit later as well. Let me add another code block here. Let's go for this one. I'm going to define a list as, let's see, 1, 2, 3, like that. And then for that list, for item in list, oops, got my colon there, print that item. And you can see here, I can run that code block. Oop, did I miss something there? 1, 2, 3. Oh, where did I miss it?
The equal sign.
Oh, you see, there's my first bug. There we go. Thank you. And there we go. 1, 2, 3. And so, so just you can see, you can run Python directly in Jupyter. I can, as I mentioned before, I can clear all outputs on it, and I can run all at the same time. And you see it renders that code super quick as well. Super, super cool stuff. Other interesting things here, as you're creating more code blocks, if you just kind of mouse over the code block, you can add the next code or the next markdown here. You can delete a code block. You can run all code above. You can run all code below. That's super interesting for data science purposes, because maybe you're trying to clean your data in a section of the Python notebook first, and then you're trying to visualize that data below. So some really interesting things that you can do with this as well. And finally, when you're done with your notebook here, let's go ahead and save this. And what I'll show you here is there's a little trick with VS Code, and I'm sorry, the dialog box there is a little bit small and I'm unable to resize it for you there, is for some reason VS Code defaults this file to a JSON file. You see the IPython notebook.json. So we definitely want to change that. So go ahead and get rid of that JSON on the back and then switch the save as type file type there so that you are actually saving a Python notebook. And I'm going to call this one hello. And that's how you save. And now you basically, in your editors here, we've now got our hello IPython notebook with our notebook there. And so that is just basically the basics of Jupyter Notebooks. What's great is you can save it like a document, you can fork it, you can change it, and all sorts of things there as well. So I'm going to turn it back over to Ricardo now to take us a little bit more into our spaceship scenario.
All right. So if you have been following along the Microsoft Learn tutorial, we will get to one of the pages, the unit 4 of 6. It's called Use Advanced Commands. Let me show that. So here, so this is what we'll be doing. I will show a little bit more of what can be done with Jupyter Notebooks, and I will talk a little bit more about installing dependencies and some of the things, and let's see what else can we do with this. I have an empty screen, that same one that I was using. I will right click and I will create, I have this folder, it's an empty folder here that I have. It's called Enter to Python. And I will right click and create a new file here. Let me call this, it's the handbook, right? We're calling it handbook.
Sure, I called it Start Engine IPython.
Let's do it.
You can call it whatever you like.
Start engine Python notebook, and it automatically opens here. It gives me straight a code screen. I don't want the code one, so I'll just delete this. I want to markdown first. Again, markdown with Markdown, we can style text a little bit, and that's what we'll be doing. So we're going to create a visualization that is going to display 10 minutes of oxygen levels in our ship. So I'll just use the hashtag here. I don't know, so many names for this. And then I'll type in the title, oxygen levels. And then I will write down the description here, display 10 minutes of oxygen levels in your ship. And someone made a joke on the chat. A notebook as in taking notes. So yeah, basically that's what we're doing. We can run code, we can take notes, we can make very useful visualizations and a very efficient way. I think Justin hit the point here when he said this is a very useful tool that's being used vastly by academia and people in the data science and machine learning fields because of that ability. So if I hit enter here as if I was running the code, you see it's going to style that. So it gives me a title here and then the description down here. So I want to code now. But before I do that, so I will be using a few libraries to perform calculations and data visualization. I will create a bar chart here. So before I do that, remember we have installed Python, we have installed the extensions, but we will need a little bit more than that. One thing that I can do, I can install things directly into my Python installation, or Python has the ability of creating environments. So it's a specific place to run the code, and all the libraries are going to be installed locally. And that's what I'll do here. So I'll get a new terminal screen here. And I will run this command that's going to create a virtual environment in the folder called env. And then if you see it, so a new virtual environment has been created. Do you want to select it for the workspace folder? Yes. And it created a folder here. If you open it, has a little bit of information here. The libraries that are going to be installed for this execution will be stored here. Now we need to load this. So we're going to, for Windows, you're going to type this, env /scripts/activate. If you're running on a Mac, you're going to type source env/bin/activate. So these are the only differences between Windows and Mac here. But other than that, it should run the same way. As I said before, I will use a few libraries. So what we're going to do, we're going to install them using the Python package manager, which is pip. And then install, I will use NumPy, matplotlib, and ipykernel to execute the kernel here. So you type in these commands. I'm going to scroll back just to show it again. I might have done this a little faster. But it takes a little while, and then once it's done, we're going to be ready to execute the code there. And again, you can take advantage of the environment specific for your project if you want to always maintain a clean installation of Python in your machine. This way, everything that you will install for a specific project will be installed locally within that folder. And you can use multiple Python versions. You can use multiple library versions according to what you want. And for people who run machine learning, this is very significant. I'm going to scroll a little bit again here. So it's pip install numpy matplotlib and ipykernel. So this is the command you're going to run to execute everything. As soon as it's done, I'm going to collapse this. I don't think I will need this anymore. And I will start writing some code. So I need to import the libraries that I'm going to use. So these are NumPy is a very powerful Python library to deal with mathematical calculations and data storage and things like that. And Matplotlib is a library for data visualization. So I'm going to import these two and start setting up a few variables here so that we can display our oxygen levels data. So I am going to randomize some numbers that are going to be displayed. And what I'm doing here is I'm just creating a whole bunch of random data. And then I will show this data into a bar chart. So,
and Ricardo, if I could bug you for a quick second, if you select the kernel, I learned this in mine as well. If you select the kernel, then IntelliSense will then color code your code as well.
that's
There you go.
perfect. There it is. Yeah. And then it gives me IntelliSense auto completion, which is also great. Don't mind if you don't understand everything. If you're looking at this for the first time, it is okay. Just keep doing it, and then eventually you get acquainted with all the commands. And then let's run this and see what happens. And it takes a while, and ta-da! So this is our made up oxygen level data for our rocket ship. So as you can see, this is a very powerful tool. We can display data. We can you can change the colors. You can change the everything here. So I have created a 10 by 10 graph from this random numbers here. If you have a bigger data set, you can manipulate, you can create line charts and a whole bunch of other stuff. Let's play a little bit with the ship's velocity. I think that's so. I'm here. I will leave the outputs. I will not delete them. I'm adding a new code cell, and as Justin said before, you can also add it up here. If you just mouse over a little bit on the cell that you're selecting, you can click and plus code or plus markdown to add whichever type of cell you want. Then let's call and velocity 60 starts at 0, it ends at 60, and it accelerates at 9.8 units per second. Now let's calculate the time that it takes. And it's doing and velocity minus start velocity divided by acceleration. And then I will display that result using print, and then trying to reach desired velocity equals time. And then if I run this, it takes 6.12 units to reach that. And you can play along with these numbers as well. Let's say, for example, I will start at 10. And then if you run again, it changes the output here according to the values that you have there. Let me go ahead and install and insert. If I want to insert a cell in between these two here, I can actually insert it down here. You select it and then you mouse over it and you click markdown and it's going to insert. Or you can insert below and you can actually move the cells up or down. Let's go ahead and add some text. Again, this is a notebook. We need to make things clearer. So ships velocity. And then you can explain what we're doing here. Shows the time needed to get from 0 to 60 units per second given the acceleration in units per second. And if you hit here, it's going to do this very nicely. And if you're familiar with Markdown, you can use most of the Markdown features for styling. You can do it here. You can add bullet points, and you can add different text sizes, bold, italicize your text, and all the things that you can do out here. I think that's pretty much what I wanted to show here. Again, just going back a little bit, I have set up a few variables, used matplotlib to visualize data. And again, the limits here are nearly close to 0. You can do most of the things you would do in a regular programming environment. You can run it locally and visualize it using your Jupyter Notebook, just as you were coding in a regular IDE or any other place.
Yep, super powerful. And I think what's also interesting about this is, we're running this locally on our own device. But what if you had a data set with 400 million entries? You could use Jupyter Notebooks in the cloud and process that. You could change your compute target, not just locally, but you could actually make that compute target a server farm locally, a server farm that your company or your organization owns. You could make it a public cloud like Microsoft Azure. You can then determine the size of the cloud that you want to compute it with. And that's what makes this so powerful for data scientists and people who are machine learning engineers is, if you're doing deep learning, you may have heard of that term. It gets used quite a bit, but it really is about these very powerful algorithms that allow us to create inferences to basically map, to regress data, things like that, anomaly detect, cluster, and so on. But we can do that if you have a data set with 400 million things, that's going to take some time. Well, what if you had an entire cloud with thousands of virtual processors or GPUs to render images if you're going to do things like that? And so while we're showing you just the basics in today's intro to Jupyter Notebooks, I want to leave you with the idea that this is an incredibly powerful thing when we think about this is what data scientists today are using to do anomaly detection for things like cancer treatment and produce solutions like that as well. And so very, very powerful, interesting stuff. We're just tipping the iceberg here. There are so many good libraries and things that you can do as well. So thank you, Ricardo, for the demo. Again, if you didn't get a chance to install all of that or follow along with us, Microsoft Learn has all of these install steps and things like that as well. So with that, let me switch back let's do a little bit of a knowledge check now, shall we, Ricardo? Now, am I going to test you here, or should I test the audience a little bit? But please type in the chat window what you think the answers are. Let's make this a little bit interactive and be thinking about questions that you have as well. So question 1, what file extension does a Jupyter Notebook have? I might have said this specifically in today's session. What do you think, Ricardo? Please type in the chat, everyone.
Yeah, if you have the answer, you feel free to write down in the comments. I would go with letter maybe A.
I think that's a pretty good guess. The IPython runtime, IPython notebook. Yeah. I'm pretty sure there is no .o or .e. Those are just some made up errors or so. I think we got to get a little bit better with our knowledge check. We'll make the next one just a little bit harder. All right, it definitely is IPython notebook. Which of the following answers includes types of elements in an interactive notebook? A, equations and UI elements. B, charts and graphs. C, both of the above. Anybody want to type in there? I think Jim was answering A from the previous question, I believe.
Yeah.
All right. I think this one's a little bit, well, what do you think, Ricardo?
Oh, we have an answer. They have a little bit of lag. So yeah, letter C.
Robbie says C. I
Any
do
other
believe I
guesses?
typed an equation. That was the equation that I got wrong. Remember, I did the minus symbol. By the way, I was doing that because I have my actual code editor here on my second screen, and I have my stream right here. And I realized I was following along typing coding in the stream product, and there was this lag. And so I've learned a little thing about streaming here that I'm going to type over here, even though my face is a little bit off the camera or something. All right, that bought a time for, I see a C as being pretty popular here. What do you think, Ricardo?
I think that's a good guess.
Yes, we wrote equations. We didn't do a lot with UI. You can absolutely do stuff with UI, very, very fascinating. But one of the things that's so powerful about Python is absolutely the charts and graphs. That's just super, super interesting to visualize data and such. All right, question 3. Which type of the following types of content blocks are available in a Jupyter Notebook? HTML, PDF, or Markdown?
PDF would be cool.
That would be kind of interesting.
Let's see. We have 2 guesses as letter C, Markdown.
All right, let's go with it. It is Markdown.
Yeah.
And one of the things that is so interesting about Markdown is it's very useful on GitHub. So if you are relatively new to Jupyter or relatively new to GitHub, Markdown has become very, very popular, especially when explaining READMEs in GitHub repos. The open source license, like the copyrights or things that you have for your code, are very important elements of Markdown as well. So definitely something worth picking up in addition to Jupyter Notebooks as well. All right. Well, that really kind of concludes our workshop. This one was intended to be kind of brief and fun. Hope you learned a bit on this. But remember, we're just setting up for what is the beginning of a lot more exploration in Jupyter. So I would really encourage you out there to just download some Python notebooks, other people's notebooks, data science notebooks, sample data sets, things like that, and just experiment by running this code. And you'll learn by doing, you'll learn by experimentation there. But for this one, we used spaceships. We created a Jupyter notebook locally. We ran that notebook in Python with VS Code. Of course, you can do different things, like you can run this notebook in cloud computing products like Microsoft Azure, Azure Machine Learning, amongst other things. And then, of course, we described some ways to build that notebook. So otherwise, be sure to hit up our session next week where we're going to clean and prepare data. If you liked this, definitely check out Microsoft Learn. Give us feedback on these workshops as well. But then finally, I mentioned, sorry, that's our link there. I mentioned that for some of our students, student ambassadors, for other members of the Reactor community as well, if you're interested in delivering this workshop yourself, whether it be on campus, maybe you're a teacher or a STEM volunteer that wants to do this at a volunteer organization. These workshops make great resources for that because they can be done free and pretty easily as well. So if you want to get all those resources, including this video and other presenters that have presented this, you can do that at aka.ms/workshop-o-matic. It was kind of an internal working name that we called it, Workshop-o-matic, and it just kind of stuck. So there you'll find 30 or so different workshops that we've been building, all open source, all free and usable for you to pick up as well. If you are a student and you're not familiar with the Student Ambassador Program, do check it out. It's a great place to learn some leadership skills. I don't know, why am I talking about that? What do you think about the Student Ambassador Program, Ricardo?
Oh, it's amazing. I can't say anything bad about it. I've joined maybe 2 years ago, and it's been a very interesting journey of learning and connecting with people from all over the world, and having opportunities such as this one of sharing content and learning from others as well. It's pretty amazing. If you haven't done it, do it. Applications are open all year long. So if you just click there and submit your application.
Awesome. Yeah. I can honestly say that my favorite parts about my job is working with students and student ambassadors. It's what keeps me coming back year after year in that. If you are part of our Microsoft Reactors, we have lots of programs like this all the time. So check us out there at developer.microsoft.com/reactor. And so finally, this concludes our workshop portion. For those of you that are interested, we're going to have a quick Q&A for those of you interested in running this workshop yourself. And so if you would like to that, stay on the line here and type in the chat window any questions you have for us. Anything, it doesn't have to be just the scope of this particular workshop as well. But these resources are here for you, whether you're a learner for the first time or whether you want to share this with other people as well. So before we move to that, I wanted to say thank you. Thank you to Ricardo for co-presenting with me today. We'll be back next week. And yeah, I really appreciate it. So great. Well, please let me know if you have any questions here. We're online. Please type in your chat window and we'll try to answer.
While we're waiting, thank you, Justin, for this opportunity, and thanks everyone who attended this. I think it's great to see so many people interested in learning more and advancing their skills.
All right, we have our first question. Jay is asking, can Jupyter Notebooks use other programming languages? I can see how good they would be for documenting IT processes in using PowerShell, for example. This is a great question. Ricardo, you want to take a first cut? Compile on?
So, yeah, many languages. You can use Python, you can use Java, you can use R, Julia. If you're familiar with quantum computing, you can use Q#, Scala. I think Scala too. Yeah, there are many languages you can run on Jupyter Notebook.
Yeah. If I recall, Jupyter started out with Python as its primary runtime, and that was adopted by the data science community. But the concept of notebooks has now become a thing in the programming community, and people find that what really makes Jupyter so unique is the idea that you can, in fact, run code individually in these individual code blocks, put commented, test, markdown, and things like that. And so that's very unique. And so whether you're writing C#, Q#, like Ricardo was saying. So yeah, I have only actually written Python in notebooks. So I'm one who needs to maybe experiment with that a little bit more.
Yeah, I've only used for Python and Julia mostly, and a little bit of Q#.
Yeah.
We
Well,
have a question on there. Yeah.
Yeah, so Siegfried asks, I'm trying to run an example in the Learn module that requires IPy widgets. I've installed pip and installed them. I cannot run them. So Siegfried, I actually ran into this error earlier today when I was prepping for the workshop as well. We ended up deciding to use the space calculations one instead of the Start Engine part of the Microsoft Learn module, but that's what I believe you're referring to. As well. What I was able to do was I basically restarted the notebook and then waited a couple minutes for the dependencies to be installed, and then it worked for me. But I did notice a little bit of wonkiness, as a technical term, on that one. It uses a very particular dependency that is towards the end of the loading period, and so if you wait a little bit longer and reinstall, it should work on you as well. Ravi asks, Visual Studio Code shows time it took to run that code. Is that correct runtime? I don't know if I know that question on a sort of technical level. That'd be one I need to ask one of the product engineers if it's actual runtime or or just the amount of what you are visually observing. So I don't know, but I suspect that there would be minor differences between those two if there are, but those would be compounded if you're running that data set with 400 million records, as I mentioned. Chandra is asking, can you write your own custom language or engine to process code blocks? What do you think about that one, Ricardo?
So you can actually do that. In fact, Jupyter is open source. There are many kernels being developed. If you go to, I think it's github.com/Jupyter, and you can see whatever is being developed now. And even if you want to contribute with others kernels for other languages, you can do that.
Yeah, absolutely. Yeah, it has incredible amounts of extensibility. A lot of things are open source. The Visual Studio Code itself, the overall product itself, is available on GitHub and is open source. And so you can contribute to it and parts of it or extensions to it as well. Jay asked, do code blocks share a single execution context or are they all separate? For example, if I set a variable in one code block, can I use that variable's value in a later code block in the same notebook? Ricardo, what do you think?
Yes, if it's in the same runtime. So it's going to load a kernel runtime. Let me just simplify it that way. And everything, if you declare, the only thing you can't do is you declare something and not run it. But as soon as you run it, let's see if if you look down, let me see if I can share my screen just to show something real quick.
I ran into this problem early when I was learning Jupyter Notebooks because I would run individual code blocks, but I would forget to run my library earlier on. And so it's a really good question, Jay, especially for beginners, because you got to remember to run them in the right sequence. That's why that little play down arrow or play up works really well. You know.
So yeah, let me show something real quick here on the screen that might help that. So if you see down here on the bottom, let me try to maximize. Let me zoom this a little bit more. So if you see here, I have the number 1. This means that this was in the execution order, this was number 1 being executed. And then I have number 3 here because I think I actually ran this 2 times. But anyway, you have to pay attention to the execution sequence. If you declare something up here, and if you import things here, set up variables, create functions, define everything. You can even define classes and do more complex stuff. As long as you call something in another cell after that first cell was executed, that is going to work just fine.
Yeah. Another thing you might encounter is if you do run something after you've pip installed your dependencies, sometimes you'll get kind of a big gobbledygook. This has already been installed. This has already been installed. This has already been installed. That is normal. It doesn't look very good, especially if you're doing a stream and a demo like we were. But just so you know, like next time you see that, don't be alarmed by it. That's a normal behavior when you go to rerun the notebook once you've added those dependencies as well. Siegfried is asking, please elaborate on the environment you created. So Ricardo, you did that a little bit where you were in your terminal and such, which is not part of our Microsoft Learn module, but is very, very valuable, especially as you're doing more advanced things. So can you share a little bit more about why you do that and what are some of the reasons you do that or not do that?
So yeah, as I said a little bit about it, if you set up environment locally, an environment as I did, you can pretty much control which version of Python, which version of the libraries you're running, and you do it locally within the scope of that particular project you're using. This way, you can use multiple, if you're working on multiple projects that will require different versions. Let's say, for example, if you're working with TensorFlow, not anymore, but mostly we would shift into working between TensorFlow 1 and 1.x and 2.x for different projects. And you wouldn't want to have that installed into your main Python version because then you would have conflicts of versions there. So an environment is basically a way of containerizing your installation of Python within a specific project. And then the second command that I've typed, I loaded that specific kernel that is going to be executed whenever I run my code, whenever I install any packages or libraries or modules or anything that I am going to use within the scope of that particular project.
Mm-hmm. Cool.
I hope that's clear.
It's very valuable because, sometimes you're working with a project where you only have certain variables that you need within the project that you're doing. And let's say you're a developer or software engineer and you're working on multiple projects, or maybe you have a pre-production and a production environment or things like that. These are ways to abstract that, or as you use the word, containerize.
Yeah.
Which there's a whole session,
Yeah.
a whole Microsoft Reactor learning session on what containers are, and Docker and Kubernetes, and why those are important. But the short version is it's really nice to execute your code all within one little, I call it a sandbox container, a place where you store this project's code in this particular way. Great. All right. Well, I think we are out of questions. But again, thank you, Ricardo. Thank you, everyone. Really appreciated the chat and asking questions. I love that as well. So I hope this was valuable for you. We'll see you next week. And thank you very much.
Thank you. See you, everyone.
Cheers.